different things we can do with sorting. We can sort our arrays alphabetically, ascending, so we can put them in ascending order or descending order. The two algorithms that we're interested in talking about, and there are other sorting algorithms, but the two that we're going to talk about are what's referred to as the bubble sort and the selection sort. Let's start with the bubble sort. So the bubble sort can arrange your array in both ascending or descending order. And the basic algorithm for this sort is that it's basically going to, well, the first step. So I'm going to write down the algorithm, and then we'll write down the actual code for how you would do this. So the first step is that you're going to compare the first two elements of your array. And if you find that those two elements are out of order, you're going to swap them. So we're going to compare the first two elements. And if out of order, we're going to swap them. And then we're going to compare the next two elements, and if they're out of order, we're going to swap them. So compare the next two elements. Now I'm going to put swap if out of order. And then you can probably see where this is going. We're going to basically just continue this until we get to the end of the array. And so we're going to go through the array. We've swapped each element as we've found that it's out of order. And we're going to need to pass through the array again. So after we go through the array once, and I think this will make more sense once we look at some code. But basically, you're going to compare the first two elements, swap if they're out of order. So let's say you want it in ascending order. Like let's say you have a 5, let's do 10, 5, 6. So you're going to compare these first two elements. Let's say you want this in ascending. These are out of order, so you're going to swap them. So then you're going to have 5, 10, and 6. And then you're going to compare the next two elements. And this is really the same array. I've just written the different orders. So this is after we've done our swap on the second line. So now we're going to compare the next two elements, which have 10 and 6. We're going to swap the 10 and 6 if we're trying to put the array in ascending order because 10 is greater than 6. And we're going to keep going through the array and doing that. We're going to, after we finish going through the array, the assumption is that the largest element is going to be at the end of the array, but the array isn't necessarily in order yet, so we'll have to go through the array again, and we'll keep going through the array repeatedly until it's completely in order. So I'm just going to put, for the third step, pass through again, and then we're just going to keep repeating this until the array is in order. So let's write down some actual code for this algorithm, and then we'll look at an array and look at this step-by-step how it's actually working. So let's say that we have a function. We're just going to call the function bubble sort. And it's a void function, isn't returning anything because it's modifying the array from the function. So since the function isn't returning anything, we're just going to use a void return type. And then we need to send the function our array, and we need to send it the size. All right, so this is our function header. Now let's look at what's going to go in the function. First of all, we're going to want two variables. We're going to want we want a variable that's holding the maximum element in the array, and we want a variable that's holding the index. So I'm just going to do int maximum element, and then index. And then we've already said that we're going to be repeatedly passing through the array. So we're going to use a for loop to do that. And this first for loop might be kind of confusing. I think this will make more sense once we get some of the code written down and then look at what it's doing. So I'm just going to write the for loop. So we've already declared the max element of the array. This is equal to size minus 1, and then max element greater than 0, max element minus minus. So this for loop is a little bit different from the ones that we've been looking at previously because it's going from a large number to a smaller number. And we're going to see how that works with the array sort in a second. We're going to need another for loop. This one is for index equals 0, index less than max element, and then index plus plus. And then this is where we're going to compare our two elements in the array to see if one is smaller or larger and to see if we need to swap them. So we're just going to say if array index is greater than index array plus 1, so we're comparing it to the element next to it. So we have our current index, so we have the element of the array for the current index, and we're comparing it to the element that's right next to that element we're interested in. So if that element is greater than the element, so let's say so these are the two elements we're comparing. Let's say we have 6 in the left one, 5 in the right one, and let's assume we're sorting this in ascending order. Then we're going to say if array index, so that's referring to this one, is greater than index plus 1, that's referring to this one, we're going to swap them because we want to put this in ascending order. And so we're going to have a function that presumably, this is array index plus 1. And then, so if that's true, we're going to swap the two elements. So this is good. So let's just assume that we have a function that's going to swap the two elements. So we would send it these two values. So we'll send this swap function these two values, and it'll swap them. And then I'm going to write down an array, and we're just going to go through step by step what this is doing to sort the array, because I think with these two sorting algorithms, the easiest way to see how it's working is to just see the code and then step through an array step by step and see what it's doing. So let's say this is our array that we want to sort. So let's say we have 10, 5, 40, 35, and 6. And so what I want to do is I want to write down next to the array what the different variables are, and then we can just look at the logic and see what's happening with the array. So first of all, let's say that we have this 5-element array that we've sent to this function. So size is equal to 5, and in our algorithm we have that for this first for loop, so our outer for loop. So for this algorithm we have an outer for loop and an inner for loop. Our outer for loop, we've set our counter to this variable called max element, which is size minus 1, and index is equal to 0, so we'll write that down. And then now, so we're here, so I'm just going through this code line by line and writing down what each part of it is doing. So now we're at the if statement. This is going to be comparing 10 and 5, so it has, is 10 greater than 5? Yeah, that's true. So this is going to swap, so it's comparing 10 greater than 5. That's true, so it's going to swap these two elements. So let's redraw our array. And now we have 5 first, 10, and we still have 35 and 6. All right, so it's gone through the if. All right, so now we just went through the if statement. Now we're back up to this for loop right here. It's incremented index, so now let's just separate these. So index is equal to 1. And let's actually rewrite all of the variables. So size is still 5. Max element is still 4. But index is now equal to 1. And so if we go into this if statement, so now we're here, it's saying, and let's number our array, so 1, 0, 1, 2, 3, 4. So index is 1, so this is saying, is 10 greater than 40? Yeah, so this is false. So there's not going to be a swap this time. Let's redraw our array. So we still have 5, 10, 40, 35, and 6, right? Okay, so now we're back. So we've gone through this if statement. Now we're back at the for statement. Index is incremented again. So what is index equal to now? Yeah, now index is equal to 2. So now we're comparing, 2, 3, 4. Now we're comparing, is 40 greater than, yeah, okay, yeah. Is 40 greater than 35? Yeah, that's true. So it's going to swap these two elements. So put swap, draw this again. So now we have 5, 10, 35, 40, and 6. All right, now we're back. So we're still inside this inner for loop. Now what index is incremented, so index is equal to what now? Yeah, so now index is equal to 3. 0, 1, 2, 3, 4 is, so the comparison we're making is 40 greater than 6? Yes. Yeah, so we're going to swap these. All right, so let's redraw this. So now we have 5, 10, 35, 6, and 40. All right, we've gotten to the end of this inner loop, because notice how if index is less than max element, on our next iteration, index is equal to 4. Well, max element is also equal to 4. So it's going to exit this inner loop. And if we go back up here and look at the code, now we're back at this outer for loop again. So we've gone through the array once, and we've swapped elements that are out of order as we've come to them, but notice how the array is still out of order. Like we have the maximum element, or the maximum element at the end of the array, but we have a 6 here. That's not quite out of order. That's still out of order. And if this were a longer array, we'd probably have more elements out of order as well. But the point is, we now have the maximum element at the end of the array. So if we look at this outer for loop, we can decrement the max element because we don't need to compare the end of the array anymore, because we already have the maximum element at the end of the array. So let's go down here and write down. So max element is decremented. What is it equal to now? Yeah, 3. So we're just going to step through this array and do the same thing. We're back at the inner loop again. So now index is equal to 0 again, so we're back at the beginning of the array. And so our first comparison is 5 greater than 10. That's false, so yeah, we're not going to swap those. What about, next it's going to compare, is 10 greater than 35? No, so it's not going to swap those. Is 35 greater than 6? Yes. So now we're going to have a swap. So let's redraw this. So we have 5, 10, 6, 35, 40. And then this is going to finish out that inner for loop, because I believe at this point our index is equal to 2, so it's going to exit the inner for loop now, and we're going to be back at the outer for loop. It's going to decrement the max element. So what is max element equal to now? Yeah, 2. Let's just number this again. All right, now we're back at the inner loop. So we have 5 greater than 10. That's false, so it's not going to swap those. What about 10 greater than 6? That's true, so it's going to swap these. So let's redraw this. So now we have 5, 6, 10, 35, 40. This is going to run through the inner loop again. These are all in order now, so it's going to run through the inner loop and not make any more swaps. And then it's going to decrement the max element is equal to 1. And I believe at this point, let's go up here and look at this. So it's going to, so it's going to run through it one more time, and then it'll exit and be done, because the outer loop will become, the condition will become false. So the reason why this is called bubble sort is because we're kind of bubbling the values to the beginning of the array. So see how they're kind of, like we're taking this 6, which 6 is far from being one of the larger numbers in the array. And if we look at what we're doing, the 6 moves back one spot, and then it moves back another spot, and then another spot until it's in its correct position. And so the values are kind of bubbling into place. They're not being put in the place automatically. Like, we're not putting them directly where they need to go. They're just kind of moving one step at a time. Look at the advantages and disadvantages of this bubble sort. So advantages. What do you think some of the advantages or disadvantages are?
I switched to the array multiple times.
Yeah, that's one of the main problems, because so it's basically inefficient, because this is going to be a really slow sort for large arrays, because we're going through the array lots and lots of times. So it's inefficient. So one of the advantages I would consider with this is that it's pretty easy to implement. It's not a really complicated algorithm. I'm not going to say that nested for loops are super easy to understand, because they're kind of confusing. But compared to some of the sorting algorithms, this one is pretty straightforward. You're just comparing the values and then swapping values. So I would say that this one, like, one of the advantages is that it's easy to implement and to understand.